In this video, we present the SPICE-HL3 dataset, a single-photon, inertial, and stereo camera dataset for exploration of high-latitude lunar landscapes. Upcoming lunar missions aiming at exploring high-latitude regions, such as NASA's Viper or China's Chang'e 7, must cope with one of the most challenging visual environments ever faced in planetary exploration. At the lunar poles, the sunlight is always low on the horizon, and with minimal light scattering, the terrain is filled with stark, high contrast and rapidly moving shadows. These intense shadows create areas of total darkness, known as permanently shadowed regions, where some of the moon's most valuable resources and scientific discoveries are hidden, frozen for potentially millions of years. In this work, we introduce a unique dataset recorded at the Lunar Lab from the Interdisciplinary Research Center for Security, Reliability and Trust at the University of Luxembourg, an indoor test facility designed to mimic the photometric conditions found across different lunar latitudes. The facility is equipped with a 600-watt spotlight, whose luminance can be fully adjusted to simulated different sunlight elevation angles and daylight conditions. The testbed is filled with 20 tons of coarse basaltic gravel, along with rocks and craters of varying sizes and shapes, which introduce additional shadows and occlusions. Black-coated walls and ceilings surround the testbed to minimize secondary light reflections, simulating the absent lunar atmosphere. 12 OptiTrack motion capture cameras spread around the laboratory are used to capture sub-millimeter ground truth positions of the rovers. We present measurements from 7 distinct rover trajectories. Each trajectory includes time-synchronized monocular and stereo image sequences, inertial measurements, and wheel odometry data captured under different illumination conditions, with variations in the type of movements performed, the speed of the rover, and/or the type of cameras used. Our goal was to record as many variations in movement and illuminance as possible to closely replicate the spectrum of operational conditions expected during real missions to the lunar poles. We tested 7 different illumination conditions from lunar dawn to nighttime while simulating rover navigation with and without the aid of headlights. For the first time, we are introducing data recorded with a single-photon avalanche diode, or SPAD, camera. SPADs are cutting-edge imaging devices capable of detecting the arrival of individual photons with extremely high frame rates and a broad dynamic range. Unlike conventional cameras, which capture a digital signal based on accumulated light intensity, SPADs provide a direct binary output, streaming a fast sequence of 1 bit per pixel frames, which could be later integrated to digitize images of any desired bit depth. We hope this dataset becomes a valuable resource for engineers and researchers developing vision-based autonomous navigation pipelines for lunar exploration. For more details on this dataset, check out the associated paper. You can download the full dataset directly from our Zenodo repository of the same name. All links are available in the video description.